Hey, algebra students, this is your test review. So hopefully you're watching this on Wednesday, what would Wednesday be, the 10th. I wanted to meet live with you guys. I don't meet live with you guys so much. Y'all are so not needy. All my other classes are very needy, but you guys are not. But anyway, I'm actually out of the building today, the 10th. And so I thought I'd probably need to go ahead and pre-record this for you, so that you can take your test on the 11th. Now, all your assignments are due. If you have any zeros, you have until Thursday night to complete all of those assignments. I have to post your report card grades. The only thing I'll accept on Friday, the 12th, is the extra credit. I gave you an opportunity to do a little extra credit. And so if you do that, I hope you do, but I have to have it by 4 o'clock, okay? Because we have a deadline on when we get our grades in. All right, so let me share my screen with you so we can look at some of these practice problems. All right, so the first problem here asks us to classify this polynomial. So we classify in number of terms. By number of terms, we classify 1 monomial, 2 binomials, 3 trinomials. And then if you have more than 3 terms, we just call it a polynomial. So since we have 4 terms here, we're just going to call it a polynomial. And then you need to put them in order by the biggest exponent to the smallest exponent. So we've just ordered this polynomial. So like I said, there's 4 terms, so we're just going to call it a polynomial. And since the biggest exponent is 4, we would say it's a 4th degree polynomial. Alrighty, 4th degree polynomial. Number 2. All right, which of these is a 5th degree trinomial? So trinomial, we're looking for 3 terms. Our biggest exponent is a 3, so it's going to be letter B. Letter B is a 5th degree trinomial. If it asks for a 5th degree binomial, right, that would be C. So number 3, we're going to add. That just means that really what we could do is just drop all of our parentheses and combine like terms. So we have 3x cubed plus 5x cubed is 8x cubed. We have negative 5x combined with positive 7x. So that would be positive 2x. Finally, we have negative 8 combined with positive 3, which is negative 5. And then that's it. That's our final answer. Now, when you have a subtraction sign in front of a set of parentheses, you are going to distribute that negative sign. It's just like multiplying everything by negative 1. So we bring 3x cubed over. The first set of parentheses don't change because there's not a negative in front of the parentheses. Now we distribute that negative sign, minus 7x minus 3. Now we're going to combine like terms. Don't forget that includes the sign in front. So we have negative 2x cubed, and then negative 12x, and then minus 11. I hope you guys are trying these by yourselves, and then you are just looking at the video to check your answers. So when we multiply, so this is a monomial times a monomial. So there's no plus or minus signs. So if you don't have any plus or minus signs, it's 1 term. So basically what we're going to do is multiply our coefficients. 5 times 2 is 10. And then for all of our numbers that have the same bases that are being multiplied, we add those exponents. Y to the 11th and Z to the 8th. All right, how you guys doing? Everybody getting on 100 so far? Now for this one, when you have a power raised to a power, the rule is you multiply those exponents. So even when you don't see an exponent, that means you still have to distribute that 2. So if you don't see an exponent, that means it's a 1. So 7, so our exponent of 1 times 2 is 7 squared times b squared times a squared times b squared times c to the sixth. And then of course we can square 7. So this is the best answer. That is the best answer. All right, so we're going to distribute the 2 to the first set of parentheses, the 3 to the second set, and then there's no plus or minus signs. That means this is a multiplication problem. All right, so 6 squared is 36, x to the fourth, y squared times y to the sixth, right? And so now we have two numbers with the same base being multiplied. So we're going to add those two exponents and we get this as our final answer. Number 8, we're going to simplify those coefficients. So negative 25 divided by 5 is negative 5. Negative 5 is a whole number, so it stays in the numerator. And then 12 minus 10 is positive 2. There's more a's on the top, so my a stays in the top as my answer. And then 8 minus 3 is positive 5. There's more b's on top when I cancel or simplify, and so that's my final answer. I have nothing left in the denominator but a 1. All right, here we're going to distribute that 3 to everything inside the parentheses. So we get x to the 6th over y to the 3rd. And that's it. All right, I think I have to erase my board here. All right, number 10. Now on this one, we're distributing using the distributive property. So we're going to multiply our coefficients, and the numbers that have the same bases, we're going to add those exponents. So the first one is 36 x to the 3rd plus 18 x to the 4th minus 9x squared. And that's our final answer. We simplified. All right, then number 11, we're going to multiply 5 times all three terms, 5x times all three terms, and then negative 6 times all three terms. So 5x times 3x squared is 15x to the 3rd minus 20x squared minus 15x minus 18x squared plus 24x plus 18. So now we're going to combine all these like terms. So those are like each other. These are like each other. So our final answer is 15x cubed plus 4. Nope, just kidding. That's not right. That would be negative 38, right? So negative 38x squared plus 9x plus 18. Y'all check me now. If I'm wrong, let me know I'm wrong, okay? All right, now let's look at number 12. It says, if this times this equals az squared minus b, what is the value of a? Okay, so basically we're just foiling this and we're going to see what that first either number or coefficient or variable is. So we have 8z times 8z is 64z squared. Now we're doing 8z times 9, so plus 72z, and then minus 72z. So those two middle terms will cancel out. And then finally, minus 81. So it asks what the a is, a times z squared, so the value of a is 64. And that's the difference of two squares, isn't it? Find the quotient. Oh, there we go. All right, now remember when you're dividing, you have to divide. When you have a number on the bottom and multiple terms on the top, you have to simplify everything by the same number. So we are simplifying everything by negative 6x. So we're thinking of this as 3 different terms, right? And it's easier if you just write them out, then you can see it. All right, so the first one we can divide, so our 6x is going to go away because everything's divisible by 6x. But 6 divided by 6x is -1. And I'd have, if I subtract my x's, I'd have x squared left. So -1 times x squared is -x squared. A negative times a negative, or excuse me, a negative divided by a negative is a positive. So -18 divided by -6 is +3, and I would have 1x left over. And then negative divided by a negative is +2. That is the quotient. All right, let's look at this one. The lengths of two sides of a triangle are shown below. Of course, we know that triangles have 3 sides, and they give us the perimeter of the triangle. Okay, so the question is, what is the total of the 2 sides we're given? So of course, total in math means we're going to add. So we have 8x squared minus 5x minus 2 plus side 2 would be 7x minus x squared plus 3. So now we're just combining like terms. We have 8x squared minus 1x squared would be 7x squared. And then -5x combined with +7x is +2x. And then -2 plus 3 is +1. So letter A is 7x squared plus 2x plus 1. Now it asks, what is the third side of the triangle? Well, we know the perimeter and we know the combination of 2 sides. So to get the third side, what are we going to do? We're going to subtract. So we take our total perimeter, and from that, we're going to subtract the sum of our first 2 sides. And make sure you put those in parentheses, because hopefully that will remind you to distribute that negative sign to everything in the parentheses, okay? So I'm bringing down 4x to the third minus 3x squared plus 2x minus 6, and then minus 7x squared minus 2x minus 1. Now we combine like terms. So we have 4x to the third. And then we have -3, -7 is -10x squared. Gone, gone. And then we have 2x minus 2x is 0. And -6 combined with -1 is -7. So this is the length of our third side. Hope that makes sense, you guys. All right, and then the last question says, do the answers for part A and part B show that the polynomials are closed under the addition and subtraction? So there's that little closure rule, and this is just a freebie. So you have this question on your test. So the answer is yes, it shows that they're closed. It says part A shows that when polynomials are added, the result is also a polynomial, which is called the closure property of addition. Part B shows that when polynomials are subtracted, the result is also a polynomial. So since I'm giving you this answer, I expect that for you to write that on your test, okay? If you don't watch this video and you have some crazy answer for part C, you're gonna miss it. All right, guys. All right, let's do the next one. It says a rectangle has sides measuring 6x squared plus 4 units and 2x plus 11 units. What is the expression that represents the area of a rectangle? Well, how do you find the area of a rectangle? You multiply side times side, right? So this times this. So we're going to FOIL it. So first 6x squared times 2x is 12x to the third. And then 6x squared times 11 is positive 66x squared. And then 4 times 2x is plus 8x. And then we have 4 plus 11 is 44. All right. So, oh, it's already simplified. You can't add anything. These are unlike terms. All right, so we got the expression would be this. This is the expression, right? And then when it tells me to simplify my expression, this is what I get. This is my expression simplified. And then finally, part B says, what are the degree and classification of the expression obtained in part A? So the expression obtained when we simplified was, it has 4 terms. So what do we call a 4-termed thing? We just call it a polynomial. And then by the degree, what's the biggest exponent? So this would be a 3rd degree polynomial. Polynomial. All right, if it had 3 terms, we call it a trinomial. 2 terms is a binomial, so on and so forth. So once again, guess what? I'm giving you an answer. How does part A demonstrate the closure property for polynomials? And the answer is, when 2 or more polynomials are multiplied, the result is also a polynomial. Part A demonstrates the closure property for polynomials because the solution to part A, blah, 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 that is a polynomial. Now, the only one that we don't have a closure property for is division, but that's not on your test. That particular question isn't on your test. Okay, all right, let's look at this problem. A bucket of paint has spilled on a tile floor. The paint flow can be expressed with the function R of t equals 3t. R of t equals 3t, where t represents time in minutes and R represents how far the paint is spreading. The flowing paint is creating a circular pattern on the tile. The area of the pattern can be expressed as the area is equal to pi r squared. That's a lot, you guys. However, part A is going to help you. Find the area of the circle of spilled paint as a function of time. This is basically, it's telling us what we're going to do. Show your work. So on this problem, you work from the inside out. So you take what's inside the brackets, which is R of t, and I hate that this is on 2 different lines, but here is R of t right there. R of t is equal to 3t. So we're going to take 3t and implant it into A of r. So what's our variable? Obviously, we know pi. Pi is not a variable, right? It's a symbol. So in r's place, we are going to write 3t. We're plugging it in. So A of r is equal to pi times r squared, and r squared is going to be 3t squared. Do you understand? You take what's in the brackets and you plug it into the other one. So we can, we are going to distribute that 2 to everything in the parentheses. So we're going to write pi times 3 squared t squared. Well, can I simplify that? Bring that 3 up to the front. 3 squared is 9 pi t, whoops, that's an r, t squared. And that is the answer, you guys, for part A. Okay. So now that's the answer for part A. All right, letter B. How large is the area of spilled paint after 10 minutes? So what is T? T is time, right? So we're going to substitute 10 for our T. And because we have a symbol, which is pi, we're also going to use 3.14 to show for pi. So we're going to take 9. We're going to multiply it by pi. And then we're going to multiply it by time squared. Or I could put the 2 on the outside. It doesn't matter. So now we just simply put that right into our calculator. We type 9 parentheses 3.14 parentheses And I know that 10 squared is 100, so I'm just typing 100. So how large is the spill? The spill is 2,826. What is our units? It doesn't say. All right, anyway, how large is the area? It's 2,826 squared units after 10 minutes. Okay, now you're not going to have the same problem, obviously, but you're going to have one where hopefully this example can help you on your test tomorrow. All right, and then the last one, I believe it's the last one. Is it the last one? It is the last one. All right, it says consider the functions blah and blah. What is the value of f of g of 5? All right, I'm going to erase all this stuff. So what did I say? Where do you start? You start in the middle, and then you take it out and you plug it into the other one. So since g is in the middle, they don't have g of x, they have g of 5. So that means the first thing we're going to do is take g of x and substitute 5 for x. So we're going to substitute 5 squared minus 1. So we have 25 minus 1, which is 24. So we took what was inside and we're going to plug it into what's on the outside. So we're going to plug our answer of 24 into f of x. So if x is 24, 3 times 24 minus 2, well, 24 times 3 minus 2 is 70. And that's the final answer. Okay, that's the final answer. All right, I hope this helped you guys. If you need help, since I'm not in the building on Wednesday, before you take the test, don't open the test and then ask me for help. Don't cheat. If you want to go over some of these before you start taking the test on Thursday, that'll be fine with me. I'd love to help you if you need it and you're not cheating. All right, you guys, well, I know that you're going to do great. Get all your work in, no zeros. My honors algebra students should not have any zeros, definitely. Have a great day, and I will see you guys later.